What if Earth had a large elliptical orbit? Imagine basking in a warm summer day, when suddenly, everything starts to burn. Not long after, your entire world freezes into a giant ice ball. This isn't science fiction. This is what could happen if Earth's orbit stretched from scorching Venus all the way out to icy Pluto. This is what if, and here's what would happen if Earth had a massive elliptical orbit. Right now, Earth's orbit around the Sun is almost a perfect circle. The difference between its closest point to the Sun, called perihelion, and its farthest point, aphelion, is only about 5 million kilometers, or roughly 3 million miles. That might sound like a big number, but in space terms, it's barely a wobble. Earth stays comfortably within what astronomers call the habitable zone, a sweet spot around a star where temperatures are just right for liquid water to exist. And as we know, liquid water is one of the key ingredients for life as we understand it. But what if that gentle, near-circular orbit was replaced with something far more dramatic? Imagine Earth's orbit was stretched into a long ellipse, a shape more like a flattened oval than a circle. At its closest, Earth would dive toward the Sun to about the same distance as Venus, only 108 million kilometers away. Then, on the other side of its orbit, it would slingshot outwards, drifting billions of kilometers away, past the orbit of Neptune, all the way to the frozen edge of the solar system where Pluto orbits, at nearly 6 billion kilometers from the Sun. This would be a radical change in Earth's cosmic journey, one that would transform not just our seasons, but the very nature of life on the planet. To understand the consequences, we have to look at the forces at play. The Sun's gravitational pull is what keeps us in orbit in the first place. But that force isn't working alone. The gravitational influence of other planets, especially massive ones like Jupiter and Saturn, also tugs at Earth's orbit ever so slightly. These small nudges, combined with Earth's own momentum, create the current slightly elliptical path we follow each year. Now, if a dramatic shift occurred, maybe from a cosmic event, a rogue planet passing nearby, or a massive disruption in the solar system's gravitational balance, Earth's orbit could become wildly elongated. In this new orbital pattern, Earth wouldn't spend a steady, predictable 365 days circling the Sun. It might take years or even decades to complete a full orbit. And during that orbit, the planet would pass through extreme zones of both heat and cold. The habitable zone, that magical range of distance where water remains a liquid, is not huge. It stretches from roughly 0.95 AU to 1.37 AU, 1 AU being the distance from Earth to the Sun, about 150 million kilometers. Our planet sits right in the middle, but with a massively elliptical orbit, Earth would repeatedly leave and re-enter this zone. The result? Long periods of intense heat followed by deep freezes, each one capable of wiping out ecosystems, disrupting weather patterns, and destroying any form of stability life relies on. Even minor changes to Earth's orbit have been linked to past climate shifts, like the ice ages. These subtle variations, called Milankovitch cycles, involve small wobbles, tilts, and shifts in Earth's orbit and rotation. Now imagine not small shifts, but a complete orbital makeover. Instead of a gradual climate drift over tens of thousands of years, we'd experience rapid and violent climate swings over just a few years. During the closest point in this orbit, Earth would roast under the Sun's glare. Deserts would expand. Ice caps would melt. Oceans might evaporate. Then, as the planet sped away from the Sun, things would cool, first gradually, then drastically, until entire continents were buried in snow and ice. And here's the scariest part. This wouldn't be a one-time event. It would happen again and again, every time Earth completes one of these extreme elliptical laps around the Sun. Life would have to survive wild swings between two deadly extremes, neither of which resembles the world we know today. In this version of reality, Earth becomes a kind of cosmic commuter, rushing toward the Sun like a moth to a flame, then retreating into deep space like a frozen ghost ship. Our home, once so steady and predictable, becomes a chaotic traveler in a solar system that was never designed for such a ride. So the question is, could anything survive such a journey? As Earth begins its plunge toward the Sun in this new exaggerated elliptical orbit, our planet quickly transforms from a habitable haven into a sweltering furnace. Each day brings us closer to a cosmic heat wave, unlike anything humanity, or any life form, has ever endured. What was once a safe and stable distance from the Sun is now a death spiral toward conditions more familiar to Venus, a planet infamous for its unforgiving atmosphere and scorching surface. At roughly 108 million kilometers from the Sun, Venus receives nearly double the solar energy Earth does. If Earth were to pass through that same region, the consequences would be immediate and brutal. The first thing we'd notice? Ice would vanish. All of it. Glaciers, polar ice caps, frozen tundras, gone. Melting wouldn't happen over centuries. It would occur in months, maybe even weeks, under the relentless glare of the sun. The global sea level would rise by up to 70 meters, about 230 feet. This alone would be catastrophic. Coastal cities, London, New York, Shanghai, Mumbai, Sydney, would vanish beneath the rising tides. Hundreds of millions of people would be displaced. Infrastructure would collapse. Farmland would flood. Economies would crumble. But that's just the beginning. As more of Earth's land disappears underwater, the planet's albedo, its reflectivity, would drop. Ice and snow reflect sunlight, while dark ocean water absorbs it. With less ice and more open sea, Earth would trap even more heat. This would create a dangerous feedback loop. More heat leads to more melting, which leads to more heat, and so on. Then comes the evaporation. Warmer oceans would release vast amounts of water vapor into the atmosphere. At first, this might sound like a good thing. More clouds, more rain, maybe even some cooling. But not this time. Water vapor is a powerful greenhouse gas, and so is carbon dioxide. As these gases accumulate, they form an atmospheric blanket that traps heat with terrifying efficiency. The runaway greenhouse effect, what scientists believe happened on Venus, would now unfold on Earth. Surface temperatures would skyrocket to 860 degrees, 460 degrees. That's hot enough to melt lead. At that point, no region on Earth would be safe. Equators would become ovens. Deserts would turn to glass. Even the poles, once our last refuge, would sizzle under the pressure of this global heat trap. Simply stepping outside would be a death sentence. The human body begins to shut down at temperatures well below 50 degrees, 182 degrees, and even with protective gear, survival would be measured in minutes. Forget sunscreen. The UV radiation alone would cause severe burns almost instantly. Electronics would overheat, roads would melt, planes couldn't fly, crops wouldn't grow. Society, as we know it, would fall apart. Our ecosystems would unravel. Forests would ignite spontaneously. Oxygen levels would plummet. Pollinators would vanish. Entire food chains would collapse in rapid succession. Animals adapted to even the hottest deserts wouldn't survive this new, unrelenting heat. The oceans, superheated and acidic, would become marine graveyards. And what about humanity? Well, underground cities or deep-sea shelters might buy us time, but not much. Our bodies, our food, our buildings, none of it was built for this. Air conditioning wouldn't help when power grids fail. Global migrations wouldn't work when there's nowhere left to go. The rich might try to build self-contained habitats. Governments might attempt to launch massive geoengineering efforts. But these would be desperate moves in a game already lost. Eventually, the very water vapor in our skies would begin to break apart under the sun's radiation. Hydrogen molecules would escape into space. Over time, Earth would become dry, permanently. Oceans gone, rivers gone, rain extinct. What remains would be a hot, barren rock, a second Venus. And just like that, Earth would cease to be a planet of life. All this, from getting a little too close to our star. But don't breathe a sigh of relief just yet. After being scorched nearly beyond recognition, Earth isn't done. Now begins its journey away from the sun, toward the deep freeze of the outer solar system. As bad as the heat is, what comes next might be even worse. After enduring a hellish inferno near the sun, Earth continues its long, fateful journey through its massive elliptical orbit. Only now, it's heading outward. The light begins to dim. The once blinding sun becomes smaller, dimmer, colder. Our planet, still reeling from the trauma of extreme heat, now faces a completely different kind of threat: a deadly cosmic winter. As Earth drifts farther from the sun, past Mars, beyond Jupiter, and toward the orbit of Pluto, the amount of solar energy reaching us drops off exponentially. By the time we reach Pluto's neighborhood, over 6 billion kilometers away, sunlight is 1,000 times weaker than what we experience on Earth today. The sun would appear no brighter than a large star in the sky. With no meaningful heat input, Earth's surface temperature would begin to plummet. And it wouldn't take long. The leftover warmth from our previous proximity to the sun would quickly radiate away into space. Without thick clouds to trap heat or any greenhouse effect remaining, the planet's atmosphere would rapidly cool. Even deserts would freeze. Regions that once sizzled at over 100 degrees Celsius would now plunge to sub-zero temperatures, and then well below that. As the journey continues, temperatures would eventually drop to around 360 degrees, 220 degrees, matching those near Pluto. That's colder than dry ice, colder than Antarctica's coldest night, colder than any place humans have ever set foot on Earth. And the changes wouldn't stop at temperature. Water vapor, what little remains after the earlier global evaporation event, would now begin to condense and fall, not as rain, not even as snow, but as layers of ice. Frozen crystals would descend from the sky and coat the surface. Cities, forests, and oceans, already devastated by extreme heat, would now be buried beneath an ever-growing crust of frost. But water isn't the only thing that freezes in this deep freeze. Gases that we rely on for life, oxygen, carbon dioxide, nitrogen, would also start to liquefy and then freeze, turning into snow-like deposits across the surface. The air would grow thinner and thinner until it became unbreathable. If anyone were still alive, they'd suffocate without pressurized environments and oxygen tanks. The few places that might have survived the heat, maybe deep underground bunkers or underwater habitats, would now be threatened by the cold. Metal contracts and becomes brittle. Batteries die. Electronics fail. Pipes burst. Generators freeze. Life support systems would be tested to their absolute limits. What little sunlight remained would be too weak to grow crops or provide power. Solar panels would be nearly useless. Fossil fuels and nuclear energy might help for a while, but access to resources would become limited as supply chains collapse under the weight of global frost. The endless night would stretch on. Without sunlight, there would be no photosynthesis. Plants would wither and die. Animals that once roamed the earth would be long extinct. If any humans survived the earlier inferno, they would now face the exact opposite extreme: a world of absolute silence and bitter cold, cut off from the warmth and light that once sustained life. Eventually, Earth would resemble something entirely unrecognizable. Not the vibrant blue and green marble we see in satellite photos. Not the lush, cloud-covered home we evolved to live on, but a frozen exoplanet drifting silently through the darkness of space. Its oceans turned to glaciers. Its atmosphere collapsed and frozen onto the ground. Its surface, once buzzing with movement, now locked in place, cold and dead. And this wouldn't be a temporary phase. In this new orbital pattern, Earth could remain in this frozen state for years, maybe even a decade, before making its way back toward the sun. But by then, it might be too late. The damage done to ecosystems, the atmosphere, the oceans, and to humanity would be irreversible. Life doesn't bounce back easily from extinction events on this scale. Our planet would become a ghost world, caught in a never-ending cycle of extreme heating and deep freezing, a place too unstable for any long-term survival. And the worst part? This isn't the end of the orbit. There's still the journey back toward the sun, and the return of heat that could be even more destructive the second time around. By this point in Earth's wild elliptical journey, our planet has stopped being a predictable, life-sustaining home and has instead become something far more dangerous, a cosmic drifter hurtling through space in an unstable and chaotic orbit. In this new trajectory, Earth's path stretches across billions of kilometers, from the inner solar system near Venus all the way out to the frozen domain of Pluto. And completing just one revolution around the sun now takes a staggering 20 years. That alone would be a profound disruption. Our current calendar, based on a neat 365-day cycle, would become obsolete. So would the concept of seasons as we know them. Instead of spring, summer, fall, and winter lasting a few months each, we'd now experience seasons that span entire decades. Imagine a 5-year-long summer followed by a 10-year-long winter. The planet's ecosystems, already battered by the extremes of heat and cold, would never have time to stabilize or adapt. Agriculture would collapse. Crops that rely on specific planting and harvest cycles would fail. No region would remain temperate long enough to sustain year-round farming. Entire food systems would have to be reinvented or abandoned altogether. Humans would need to grow food in underground greenhouses, possibly powered by nuclear reactors or artificial lighting systems, just to survive. Animal migration patterns, which rely heavily on seasonal cues, would be thrown into chaos. Birds wouldn't know when to fly. Hibernating species might wake up during an ice age or sleep through the only warm years. Entire species would go extinct simply because the natural rhythms they evolved with no longer exist. And then there's the question of planetary traffic. The solar system isn't empty. Earth's new elongated orbit would cut across the orbital paths of Mars, Jupiter, Saturn, and potentially even Neptune. While space is vast and actual collisions are rare, even a close gravitational encounter with another planet could have disastrous consequences. A near pass by Jupiter, for example, could shift Earth's trajectory permanently, or worse, pull Earth into its orbit entirely. If Earth passed too close, we could get caught in Jupiter's gravity well, becoming one of its many moons. And not a stable one either. With intense radiation belts and tidal forces around Jupiter, Earth could suffer massive earthquakes, volcanic activity, or even be torn apart entirely by tidal stretching, what astronomers call the Roche limit effect. Earth's moon, our longtime celestial companion, would also be in serious danger. The gravitational stress from this erratic orbit, especially during close passes to massive planets, could disturb the moon's orbit so severely that it drifts away, is captured by another planet, or in a nightmare scenario, crashes into Earth. And without the moon, we lose more than just our nightly view. We lose tidal stability. The moon's gravitational pull is responsible for the tides that shape our coastal ecosystems, regulate marine life, and even help stabilize Earth's axial tilt. Without it, Earth's rotation could become wobbly and unpredictable. Tides would become erratic, sometimes disappearing entirely, other times surging violently inland. Shorelines would erode uncontrollably. Ocean currents would break down, further destabilizing global climate systems. And let's not forget the sun itself. As Earth swings wildly between distant cold and deadly heat, its axial tilt and rotational speed might fluctuate too. We might begin to experience days that are no longer 24 hours long, or years where parts of the planet remain in sunlight for weeks or months at a time. That's not just inconvenient. It's disastrous for biological rhythms and life processes that have evolved around the regularity of day and night. Planetary stability is not guaranteed. Earth's new orbit places it in a gravitational minefield where it could be tugged, twisted, or thrown out of the solar system altogether. Worse yet, it might crash into another planet, or be consumed by the very sun it once orbited so calmly. In this orbital chaos, the idea of Earth as a safe and nurturing cradle for life disappears. Instead, it becomes a survivor, a rogue world forced to adapt to an unforgiving, unpredictable universe. a planet no longer protected by gentle seasons and balanced forces, but one living on borrowed time, hoping not to cross paths with something much larger and far less forgiving. And if we think this is the worst it can get, think again. Because the real question now is, could life still persist? Can humanity, or anything, survive a planet this out of balance? After everything Earth has endured in its new, stretched elliptical orbit, from the searing intensity of near-solar proximity to the bone-crushing cold of deep space, you might wonder, could anything survive? The answer isn't a simple yes or no, it's maybe, but survival would depend on conditions so extreme and adaptations so radical that life on this Earth would no longer resemble what we know today. Let's start with a twist. What if Earth moved more slowly through this vast orbit? Instead of racing through the habitable zone in a matter of weeks or months, what if it lingered, giving just enough time for ecosystems to adapt, for life to take hold during the brief spring of each orbital cycle? In that rare window, new forms of life might evolve. Not like the life we know now, no dolphins, no birds, no daffodils, but extremophiles, organisms that thrive in brutal conditions, could emerge. Microbes that feed on mineral salts during the Ice Age and spring back to life when temperatures climb. Creatures that lie dormant for years, only to awaken during the warm phase to feed, reproduce, and retreat into hibernation again as Earth veers back toward the cold. These life forms would need to withstand radiation, freezing, dehydration, and extreme UV exposure. Think of them as the biological equivalent of seeds in a desert, alive, but in suspended animation, waiting for the rare moment when life becomes possible again. But even for these hardy organisms, survival would be a gamble. Each cycle of heat and cold would grow less predictable. Solar radiation could mutate DNA faster than evolution can adapt. During the frozen years, entire species could be wiped out before ever getting another chance to emerge. Life would always teeter on the edge of extinction. And what about us? For humanity, the odds are grim, but not impossible. If we somehow made it through the first few orbits of destruction, we'd need to transform our entire way of living. Forget living on the surface. That part of Earth would be uninhabitable. For nearly the entire orbital journey, our survival would depend on building fully sealed environments, deep underground or far beneath the ocean, places insulated from both the heat near the sun and the cold of the outer solar system. Entire civilizations would exist in self-sustaining bunkers, controlled climate, artificial light, water recycled in closed-loop systems, cities beneath the crust, farms lit by grow lamps, a world inside the world. In warmer periods, perhaps we'd venture topside for a few precious months or years to harvest energy, explore, or try to reclaim pieces of the surface. But it would never last. We'd always be preparing for the next environmental collapse. Alternatively, if we mastered the technology, we might build floating cities in the upper atmosphere, where conditions are more stable, hovering above scorched lands or drifting over icy wastelands, following the sliver of tolerable climate wherever it appears. But maybe, just maybe, we wouldn't stay at all. Faced with such instability, our species might decide to abandon Earth altogether. If we develop long-distance space travel, generational ships, cryogenic sleep, warp drives, this scenario might finally push us to become a multi-planetary species. We'd search for a stable, Earth-like world orbiting a quieter star. Earth, in this scenario, would become a legend, the cradle of life that we had to leave behind. And let's not forget the mental toll. A civilization that survives only by huddling in bunkers, planning for centuries of climate chaos, fighting for scarce energy. It wouldn't be the world we know. Hope would have to be engineered into culture. Belief systems would evolve around survival, resilience, and the memory of a lost blue world. But perhaps, through it all, life would persist. Because life is relentless, it adapts, it resists. It finds a way in volcanic vents, in radioactive rocks, even in the vacuum of space. If life could survive in this new Earth, it would be different, stripped down, maybe unrecognizable. but it would still be life. And maybe that's the greatest lesson of all. Not that Earth is fragile, or that climate matters, though it does. But that life's potential doesn't end when conditions become harsh. It just begins a new chapter. So could life survive? Possibly. But not the way we know it. Not easily. Not without sacrifice, innovation, and a level of adaptability we've never had to call upon before. But maybe, just maybe, we'd find a way. If just one change in our orbit could turn Earth into a scorched wasteland and then a frozen tomb, maybe the stability we enjoy now isn't something to take for granted. What do you think? Could any form of life survive such a journey? Would you rather live in fire or ice? Drop your thoughts in the comments below. And if you found this idea fascinating, share this video to spark more curiosity and conversation. Thanks for watching What If 1688. See you next time with another wild what if scenario.